Good morning, dear students. No, don't be afraid. Today we will not start any drawing class. Today we have to start the new topic of class 7, that is the second chapter, motion. Then you might be thinking that why I have drawn this type of thing here, a tree, a house, another tree, one man, or a cartoon like thing, and a car. Two cars, especially because we want to understand what is motion. It is a new thing for you and you want to learn that what is it. So let's come see. Here we have seen, assume it is you, okay, whatever your name, that whatever the name you have thinking, what is your own name, that is the name I am telling. His name is Mr. X. Okay, so Mr. X is standing here. Okay, and he has seen the car is moving in this path. Mr. X is standing here and seeing that this car is moving in the path. Whenever he has looking into it, he has seen the car is in position A. We have written here A now. A means the car is in position A. After some time, okay, the car is in position B. So that means we can say that the car is moving in this direction. This is the direction of motion of the car. It is moving. So we can say the car is in motion. But whenever we want to define it, what we have to write? Let's see. So our first target is to define motion. Then we have to understand by it. So if I am talking about the definition of motion, it tells us when a body changes its position with respect to some time and some fixed objects, then it is told the body is in motion. What is it? What is the definition? We just want to understand it. First, it is told when a body changes its position with respect to some time and some fixed objects, then it is told that body is in motion. Let's see. Here we have seen the car is moving. Okay, the car is moving. How do we understand? Now, whenever we have seen that with respect to some time, initially assume it is here, after 2 seconds, the car is here. Okay, so after some time, the car is changing its position. And the next thing is told some fixed object. See, the tree, it is fixed. The house, it is fixed. The man, Mr. X, who is standing here, he is also fixed. But the car is moving with respect to them. They are not changing their place, but the car is changing their position. So we can say with respect to the tree, with respect to the house, with respect to the man, the car is changing its position. So we can say the car is in motion. So that is the definition we have written. With respect to some time and with respect to some fixed objects, when a body changes its position, then it is told that the body is in motion. Next thing, when we are talking about motion, just parallelly one another concept has come, that is rest. Okay, that is rest. What is rest? Let's see. Now, whenever we just want to define rest, it is told that when a body does not change its position with respect to some time and some fixed objects, then is told the body is in rest. Let's see. If I am talking about the tree, see, the tree is not changing position with respect to some time. If I have come after some time, then also you will see the tree is here. If I am talking about the house, they are not changing position with respect to time. And with respect to some fixed objects are, if I am talking about the tree, with respect to this house, it is not changing its position. If I am talking about the distance between them, that is remains same. Whenever we have seen with respect to the house, the distance of the tree remains same. So it is clear that with respect to this house, the tree is not changing its position. That means it is concluded that the tree is at rest. Okay, so two things we have learned. One, if a body changes its position with respect to some time and some fixed objects, then it is motion. When it doesn't change its time with respect to some fixed objects and some time, then it is at rest. Two things we have learned. Okay, now we have to learn one very interesting thing. What is its name? Its name is frame of reference. Frame of reference. I have given you one example. See, sometimes it is happened whenever you have written something in your answer copy in exam. Whenever I have returned that copy after checking, sometimes you have come to me now with your book said it is written in the book, or you might be given correct that thing in classwork copy, but you have not given number here. What is it? It is a reference what you have taken with you. This book, this copy, these are known as the reference by which you want to convince me that this answer, whatever you have to written here, it is correct. So here we have seen whenever we have told a body is in motion or a body is in rest, there one reference is needed or many references are needed. Just like whenever we have to talking about the motion of the car, we have told with respect to the tree, with respect to the house, with respect to the man, the car is moving. So they are the reference. With respect to them, the car is moving. Whenever we are talking about the tree with respect to the heart, with respect to the man, the tree is static. It is not changing its position. So when we want to represent a motion or state of motion or state of rest, that time we need some fixed objects to represent this motion. And these fixed objects are known as frame of reference. So what is frame of reference? If I want to write the definition, so to represent the state of motion or rest of a body, we need some fixed objects. Full stop. These are known as frame of reference. Okay, so to represent the state of motion or rest of a body, we need, what we need? Now we need some fixed objects. So these are known as frame of reference. So when we represent the motion of the car, then these three are frame of reference. Whenever we are talking about the motion, the state of the tree, then this heart, this man, they are frame of reference. Okay, so without frame of reference, we cannot represent the motion of a body. Now you might be asking, sir, motion is motion, a body is moving. So why we need a frame of reference? To represent a state of motion. If I am not giving any state of rest frame of reference here, assume no tree, no heart, no man is there. If the car is moving, then you can say no frame of reference, but the car is moving. So what is the need of frame of reference? I'm telling that thing. The frame of reference is very important to represent the motion. Let's see. To understand that thing, we have to remove that portion. Okay, so I want to remove this. I think you have already written it. If you have not written, pause the video here, write it down, then come to the next point. The next portion we just want to tell here, or just we want to represent here, that is known as the rest and the motion of a body is relative. Rest and motion is relative. I'm sorry, it's R relative. And by that only you understand that why frame of reference is important. Let's see. See, whenever I am talking about the motion of the car, I am taking this 3 as a frame of reference, and you see when the car is moving with respect to this fixed object, the car is changing its position, and that's why we have told that the car is in motion. With respect to these 3 objects, the car is in motion, and the person inside the car, definitely the car cannot move by its own. Definitely one driver is there inside. Okay, and some passengers are also there. Okay, so the driver and the passengers inside the car, they are also moving with respect to these 3 objects. But whenever I am talking about any another thing, just like this person is just driving the car, but the another 2 person is sitting behind, and they are talking with each other. Sometimes they are talking with the driver. That means with respect to them, with respect to the persons, those who are sitting behind, they are static. Now you might be asking, sir, what is this thing? We cannot understand. Okay, I'm just trying to make you understand. Whenever you come to school by bus, so definitely you sit with your friends. So you are sitting in one place, beside you one of your friend is there. So whenever you are talking with your friend, the bus is moving. So is it seems the friend is also moving forward? No. You will think that, sir, we are sitting together, we are eating the tiffins which is sent by our parents, we are talking with each other, we are playing with each other, then we are static. But your parents, those who are standing outside the bus, they have seen that you are moving. The persons who are standing outside the bus, you are moving. Okay, and whenever you have gone out from the school, you are going, okay, but your friends and you just sitting together. That means with respect to your friend, if I am taking your friend is a frame of reference, you are static because you are sitting together, no one is moving. If I am talking with respect to your another friend sitting nearer to you, all of you are static. But with respect to the school buildings, with respect to the trees, with respect to some another houses, you are moving. So see the difference here. Whenever we change the frame of reference, the idea of motion is changed. With respect to these 3 objects, these 3 persons, those who are sitting inside the car, they are moving. But with respect to each of the person, or with respect to another person, the person who is inside the car is static. Assume with respect to the heart, with respect to the man, the tree is static. We have told now the tree is at rest. But if I'm talking about with respect to a person sitting in the car, whenever you have gone also by bus, by train, you have seen when you move forward, the trees, the houses, it seems to be moving backward. you are moving forward, the trees, the houses, any other thing beside the road, they are moving backward. Is it they are really moving? No. With respect to you, those who are standing inside, sitting inside, these objects which are apparently static for us, they are moving in opposite direction. So with respect to any one person inside the car, we have seen the houses, the trees, the man is moving backward. As they are approaching forward, they seems to be moving backward. So whenever I have told the body is in motion, we have to mention the frame of reference. We have to mention the frame of reference, because different frame of reference tells the state of motion or rest is changed. With respect to me who is standing outside, the car is moving, but with respect to the person, the another man's are static inside the car. With respect to me, the tree is static, but with respect to the persons, those who are sitting inside the car, the tree is moving backward. So we can say, we cannot say the body is in state of rest or motion without choosing the frame of reference. That means if I have not choose a frame of reference, we cannot say a body is static or body is in motion. If I'm talking about ourselves also, nowadays we all are inside the building, inside the room. We cannot able to move outside. That means you can say that, sir, we all are static, because with respect to the buildings, with respect to the trees nearer to our house, we are not moving outside. We are not going by the road. That means we are static. But if I am telling one thing, we all know our earth is moving around the sun. That means as we are all staying over the earth, so if earth is moving, we all are moving. So nowadays it is a time we have to enjoy the moving of earth. We will not move outside the room. So that is also one kind of message from motion. Okay, so we can say rest and motion are relative to each other. Okay, rest and motion are relative to each other, means with respect to some frame of reference, one body seems to be in motion, but with respect to some another frame of reference, the body seems to be at rest. So we cannot say the body is in eternal rest or the body is in eternal motion. Eternal means it is truth. We have told now God is eternal. Okay, we cannot change it. It is fixed, it is truth. So we cannot say that rest and motion of a body is eternal. All the things that is changed, the idea of rest and motion is changed with respect to the frame of reference. Okay, I think it is bit clear to you. Now we have to go the very interesting part of this chapter, and the part you have to remember very carefully, that is the measurement of motion. Then we'll go for the types. So measurement of motion you have done in the previous chapter also. How we can able to measure a motion. When a body moves, what the things we can able to measure here. So here we have to learn two things. Okay, later you can understood four things are there, but now we have to learn only two things. First one, distance, that we have learned earlier also. What is distance? Distance is the total path length, covered by a body. The total path length covered by a body is known as distance. Okay, so if a body moves like this path from A to B, okay, assume the whole path length is 50 kilometer. So a man starts from here and going to the point B. So the total distance covered by the man, it is 50 kilometer. Okay. If I'm talking about what is the unit of it, that also you know. There are two kinds of unit system generally we have to use. Or SI unit, if I have seen that path length. So here also the unit should be the unit of length. So unit of length in SI, that is meter, which is symbolized by small m, and in CGS it is centimeter, and which is symbolized by cm. Okay, so this is distance what we can measure for a body which is in motion. Now speed, that also we have learned in the previous chapter, so I'm not telling much on that. So speed is nothing but total distance by time. That means the total distance covered in unit time, that is known as speed, and its SI unit is meter per second and CGS unit is centimeter per second. And apart from that you have learned average speed. Okay, so that things whatever you have learned in the previous chapter, that is enough. We will not learn much on that because most of the thing you have learned in the previous chapter. Now I am going to the another interesting part of this chapter, that is types of motion. Types of motion. If you have not written this one, just pause the video in the previous part, write it down and then come to the next. That is types of motion. As we are discussing about motion, okay, we have defined it, we have learned to represent a motion, we need some frame of reference. So now the next question is that how many types of motions are there? In our book, if you see, though you have not got the book, many of you, but those who have got the book, for them I am telling, we have learned here 8 types of motion. 8. Okay, in some book it is 6, in some book it is 7, but here we have to learn 8 types of motion. Number 1, translatory motion. Translatory motion. So now I am just writing the name, then I will explain one by one. Number 2, rotatory motion. You have to write it down in your copy. Number 3, circulatory motion. Number 4, oscillatory motion. Number 5, vibratory motion. Number 6, periodic motion. Number 7, non-periodic motion. And number 8, random motion. So these 8 types of motion we have to read. So in some book only it is 7 is given, and random motion it is told as a special part, but here we have to take it in our part of motion. That is 8 types of motions are there: translatory, rotatory, circulatory, oscillatory, vibratory, periodic, non-periodic, and random motion. 8 types of motion. And now we have to start from the first, that is translatory motion. If you have not copied, pause the video here, copy it, okay, and we'll go for translatory motion. Let's see what is it, what type of motion here. Translatory motion. If I want to define translatory motion, it tells us that when a body covers same distance in same interval of time, that type of motion is known as translatory motion. First we have to write the definition, then we have to understand it. So when a body covers same length in same interval of time is known as translatory motion. So one problem is there, the ink of this pen is already empty, so that's why the color is fade. So I think you can able to understand it. When a body covers same length in same interval of time is known as translatory motion. Let's see. Assume one car is here. So now you might be asking, sir, all the definition you have given with the help of car? I have given with the help of car because the drawing of car is comparatively easier. If I want to draw a motorcycle, a cycle, it is very much difficult for me. I cannot able to draw it. Okay, so assume a car. Okay, so you have seen it is here in point A. Okay, after 2 seconds, after 2 seconds, okay, the car is here at point B. So here when the car has come, so whatever my drawing you see, in every time there are different car is coming. So it is possible only in drawing. In real life, it is not possible. Okay. So after 2 seconds, the car is coming to the point B, and the length from A to B, what is the distance it covers? Assume it is 50 meter. Okay. So assume in 2 seconds the car moves 50 meter. Next, from B to C. Okay. In next 2 seconds. So if you see in next 2 seconds, okay, the car is coming here, and here also if you measure the distance from B to C, it is 50 meter. That means in every 2 seconds, the car covers a distance or covers a length of 50 meter. So if you see whatever we have defined, when a body covers same length in same interval of time, it covers same length in every interval of time. So 2 seconds, it is the interval of time we have taken. So every interval of time the car moves a distance of 50 meter. So that type of motion we can say it is a translatory motion. Now there are two kinds of translatory motion. What are these two? Let's see. Translatory motion. So there are two kinds of translatory motions are there. One motion is known as rectilinear motion, and another one is known as curvilinear motion. Okay, so what does it mean? What is rectilinear motion? What is curvilinear motion? The rectilinear motion means when a body moves in a straight path. That means when this translatory motion occurs in straight path, that type of motion is known as rectilinear motion. Curvilinear motion, when the translatory motion occurs in curved path. When the motion occurs in curved path, that type of motion is known as curvilinear motion. Okay, so two type of motion, it is very easier. When a body moves in a straight path, that type of translatory motion is known as rectilinear motion, and when a body moves in a curved path, then the motion, that type of translatory motion is known as curvilinear motion. Okay, so if I am talking about what are the examples of translatory motion, various examples are there. Moving of car on road, cycle, okay, motorcycle, okay, running of a boy, any type of thing where the body covers same distance or same length in same interval of time, that type of motion should be known as translatory motion. Okay, or some book it can be mentioned, okay, whenever you have to read some another book also, some book it is mentioned linear motion. So what is translatory motion? That is linear motion. What is translatory? That one is only linear motion. So first type of motion, it is clear to you. And now we'll go for next type of motion, that is rotatory and circulatory. Rotatory and circulatory, these two type of motion we have to learn today, and after that the next type of motion we will learn in the next classes. Okay, because everything if we want to learn in one day, so then it is difficult for us. So next one, rotatory motion. What is rotatory motion? Okay, so rotatory motion means here one thing has come, that is rotation. That means the body rotates. How it rotates? Let's see. If we want to define it first write the definition. When a body rotates with respect to a fixed axis passing through the body itself, and the distance from the axis to any point of the body remain constant. That type of motion is known as rotatory motion. So it's a little large definition. When a body rotates with respect to a fixed axis passing through the body itself, and the distance from the axis to any point of the body remain constant, that type of motion is known as rotatory motion. So for yourself, I just want to show one example. See, this is a CD. Generally we have used. Okay, if I apply force here, the CD is rotating. You see, the CD is rotating. And you see one thing, I have taken one axis here, though I have taken one syringe here as an axis. So this syringe is acting as an axis and it is passing through the body. So this type of motion we have seen, this type of motion is known as rotatory motion. Okay, when a body rotates, you see, with respect to a fixed axis, this is the fixed axis, this syringe, okay, that passing through the body That is a rotatory motion. And the second thing I have told, the point, the distance from any point through the axis. So assume I have taken one point here. So this is the distance from the axis. So if I rotate, you see, the point is not changed. The distance from the point, it is remains same. If I have taken another point here, you see, this is the distance. So that is also remains same. Wait. All the time, the distance from the axis to the point I have taken, it is remains same. That one is known as rotatory motion. If I have seen some example here, okay, you are very much what is it? In English, it is a spinning top. In Bengali, lattu. Okay. So when it rotates, okay. So assume it is rotates in this direction. Okay. So then you see it rotates with respect to this axis. So this is the nail generally here with respect to which it is moving, and this is the axis we can assume that is passing inside the body. That is a rotatory motion. Okay. If I am talking about the fan, and you see, due to the making of video, I am just off my fan here and see my condition, what is going on. So just my suggestion is, you have to read that portion whatever we have seen, or see the video properly. Otherwise this sweat or everything we have just done here, it should be useless thing. Okay, I know many of you have opened the YouTube to see the video, but after that you just want to see some another thing, and whenever you have taken the phone to see the video, you just lose interest after listening some time. It is happened, but you have to understand it. Otherwise, that whatever the things we have done here, that work, it is not fulfilled without your cooperation. If you have not seen it, then what is the need of this sweating or everything we have done? Okay. If I'm talking about a fan also, you see the blades are rotating. Okay, so assume this is the direction of rotation. Okay, and this is the axis, we can assume it is passing through it. Okay, so axis through which the body rotates, it is just passing through the body. It is just passing through the body, and that type of motion is known as rotatory motion. And the next thing you see, if I assume one point here, so you see the distance from the point to the axis, it remains same. If I assume a point here, that distance also remains same here also. If you assume a point here, so from the point the distance, it should remain same. So the point will not move far or come closer, it will remain same. So that is rotatory motion. I think the examples of rotatory motion is clear enough. Now we will learn the next thing, the next type of motion. So translatory motion we have learned, rotatory motion we have learned. If you have not written the definition, pause the video here, write the definition, and then see the next type of motion we just want to write here, that is circulatory motion. Circulatory. Okay. Circulatory motion. What type of motion it is? It is when a body moves in a circular path with respect to some axis, and the distance from axis to the body remains same. is known as circulatory motion. Okay, when a body moves in a circular path with respect to some axis and the distance from the axis to the body remain same is known as circulatory motion. Assume an athlete is moving around a circular path. An athlete is running, okay, an athlete is running around a circular path. So here I cannot able to draw athlete. Assume the point I have made here, that is the athlete, and he is moving or she is moving around the circular path, okay, and this is the axis of rotation, that is the center, and from the center to the athlete the distance remain same. That type of motion we can say it is a circulatory motion. If I am talking about the earth, assume you know this is sun, and around the sun the earth moving in a circular path, okay, and that type of motion when the earth is moving around the sun, that type of motion is circular motion, because the distance from the sun to earth it is remain same. But if it is told that when a earth moves about its own axis, then it is rotatory motion. Then it is rotatory motion. Why? And when it moves around the sun, then it is circulatory motion. So there is a mild difference between circulatory and rotatory. We have to discuss this thing. But here you see, when a person or a runner moving around the circular path, that is a circulatory motion. When I am talking about the earth moving around sun in a circular path, that is a circulatory motion. When the moon moving around the earth in a circular path, that is also circulatory motion. And now you might be thinking, sir, circulatory and rotatory almost same. What is the difference? Whatever we have listened here, it is same almost. Then we have to see the difference between circulatory and rotatory, and that should be the last topic of today. Okay, so today we have gone little far to understand it. Okay, I don't think it is too much boring. So difference between circulatory and rotatory. Okay, so if we have seen here, we have to see there are two differences, two main differences are there. What are the main differences? Sorry, my video is disconnected a little bit. So what we have discussed, the difference between rotatory and circulatory motion. And here we have seen, in case of rotatory motion, the axis of rotation we have seen, that is passing through the body. Here you see the axis of rotation that is passing through the body. For the case of earth, for the case of spinning top, you see I have drawn a spinning top here. Here also the axis of rotation, it is passing through the body. But when a body moves in a circular motion, so here we can say in circulatory motion, axis of rotation doesn't passing through body. Why? You see, whenever a person running around a circular path, so this is the axis of rotation, that is at the center of field through which the person is moving. So the body is here and the axis of rotation is here. This axis of rotation is not passing through the body, it is passing through the field. Whenever we are talking about the movement of earth around sun, the axis of rotation is here through the sun and through which the earth is moving. So here we can say the axis of rotation doesn't passing through the body, rather for the case of rotatory motion, the axis of rotation is passing through the body. That is a big difference. Okay. Now we have to come to a little less important difference, but it is also important one. That is number 2. Distance from axis of rotation to different point of body may different distance. What is it? Distance from axis of rotation to different point of body may different distance, may have different distance. What is it? Assume this is the axis of rotation for a spinning top. I am taking one point here, so the distance is this. If I am taking another point here, you see the distance is increased. If I am taking another point here, the distance is here. So this is A, B, C. So 3 different points I have taken in the spinning top, and the length of the 3 different points from the axis of rotation is different, and it is possible for rotatory motion. But for circulatory motion, number 2, distance from axis of rotation to the body remain same. Here, so you might be thinking that, sir, here also if I have taken one point on earth here and one point is here, so that may have different distance, but comparatively to the size of the earth, the distance is so long, so we have to take the distance from the axis of rotation to the distance to the any point if I have taken on the surface of earth, that will be same. That will be same. If a person is also moving in a circular path, okay, so from axis of rotation to the man, so whenever I am talking to the point means here I have taken the whole man, and the any part of the body of this man you should take, the distance remains same. So that 2 difference is the main difference of rotatory and circulatory motion. First one, the axis in rotatory motion it will pass through the body, and in circulatory motion it doesn't pass through the body, and distance from the axis of rotation to different point of the body, for rotatory motion it should be different. It may be different, it may be same also, it may be different. And for circulatory motion, distance from axis of rotation to the body remain same. So this is up to today's work. One question I will send just now. Read the question and write the answers on your copy and keep it with you, because based on that answers, whatever the homework I have given, based on that answers I will give the internal marks. Okay, so now you know this difficult situation, when the school get open we don't know, and in this time you have to make focus your homework, because based on that you will get your marks. Okay, thank you very much.